Our session this morning is another year and more questions to answer. Lionel Kaskiw will be chairing this session, and Lionel grew up on a farm near Rossburn, Manitoba, and continues to operate the farm. He attended the University of Manitoba and graduated with a degree in plant science and began working with Farm Credit Canada. Lionel then took a job with Manitoba Agriculture as he worked with the department Southwest Manitoba for 25 years and in several positions from ag rep to crop specialist. Lionel is currently working as a crop production extension specialist out of the Minnedosa Ag Office. Welcome, Lionel.
Thanks, Laurie. I'd like to welcome everybody here today, and weather conditions are kind of typical for Ag Days. We've had, last year was maybe better, but the years before that I remember coming when it was always minus 30 and windy and cold, so we got our old Ag Days back, I guess. So today, what we're going to be doing is over the past about 5 to 10 years, I guess now, we've had a webinar called Crop Talk. And what we do with that webinar is we deal with issues what are going on during the growing season. So we have the ability to bring in our specialists to help us talk about some of these things that are going on. And then we also have the ability to let producers and industry people ask questions and kind of keep us all informed. And it's an up-to-date kind of thing, which works well because we get current questions for current situations, and a lot of times current answers as well. So I'm going to introduce our panel today. So to start, and right to my right here is Dr. John Gavloski, and everybody I think knows John. John's been around for a while too, just like myself, and John is our entomologist, and he I'm going to do some reading here if I can. He conducts, no, I'm just going to go. I got some issues reading some papers right now, so I'm just going to introduce these people because I know them so well. Because John is our entomologist. He works out of the Carmen office. John has been working for the department for years. He handles a lot of our monitoring and our insect trapping programs. He works a lot with the other provinces on developing current software, materials we can use for infield insect scouting, and basically the go-to guy if you've got a bug problem in Manitoba, you get John on the phone. Next is Kim Brown, and Kim Brown is our weeds person for the province, and Kim has been working with the department for a few years now, and she has the privilege of dealing with a lot of the new weeds moving into the province, and she'll be talking to us about them today, but those keep her fairly busy, as well as just continually working on updating books like the Weed Guide and things like that. So Kim Brown, again, you're a weed person for the province. Next is David Kaminski, and David Kaminski is our pathologist for the province. David has the privilege of working on a lot of our disease surveys, keeping us up to date on what to watch out in the fields for disease that are maybe or might be an issue for this coming year. Dave, again, has been working with the province for a while, has a lot of knowledge in disease identification and control and options we as producers and industry people have to help get these things under control and get our crop off to a good year. Finally on our panel is Anastasia Kubinec. Anastasia was working with the department for quite a few years. Anastasia was our oilseed specialist, and now she's actually got a two-purpose reason for being on the panel today. She's an industry person now. She works for Paterson grain, as well as a producer and farmer on their farm back at the Holland area, right? Yeah, Holland area. So Anastasia will be able to talk to us a bit about things that are happening, I guess, on her farm, as well as what some of the interactions she has with producers that she deals with on a day-to-day basis. So, with that, I think we're going to get started. And what we're going to do first is we're going to have each of the individuals on the panel talk a little bit. They've all prepared slideshows about what they feel are some of the issues, some of the things we dealt with last year, maybe what we can expect for next year. And then we're going to go into questions after that. So with that, I'm going to hand it over to John Gavloski. And John, take it away.
Thank you. Okay, thanks, Lionel. So what I'm going to do is go over some of the key insects from the past season. And where I can, I'm going to give you maybe some predictions or forecasts on what we might be able to expect for the coming season. And I'm going to throw in just a few tips for how to identify some of these insects and how to manage them. But I'm going to keep that to a minimum because we don't have, well, I need to get through it fairly quickly. So I'm going to start by going over what I consider my top 10 for the past growing season. So you're going to see on the screen here, I've got actually two sets of insects. The upper set of 3 off on their own, and then a bottom set. Those upper 3 insects were all of more major concern, and they were issues in all our agricultural regions. That's why they're up on their own. The other 7 below that, they were of concern, but more locally. They were things that were more, again, localized, maybe not as widespread across the province, and not to the same degree that the top 3 insects were. So those were my big 3 from the past season. The ones in bold are the ones I'm going to talk about. The other ones we can cover with questions if you have them, but I don't have time to go over all 10, or we'd be ordering supper for you guys, so I'll stick to those 5. I'm going to start with flea beetles. So flea beetles, even though we've got neonics and possibly add-on seed treatments on all the seed, there was still foliar spraying last year. In fact, in all the agricultural regions, there was foliar spraying going on. But on maybe a positive side, there was less foliar spraying than the years before. So for some people, instead of doing 3, 4, or more foliar sprays, they were doing 1 or 2 last year. And some didn't have to spray at all. So again, the foliar spraying was happening, but it was reduced compared to previous years. So one of the questions that I've been getting is, why were we seeing less flea beetles? What was happening here? And I don't think we're out of any flea beetle cycles. So I think what happened here, one of the things that puts canola at a greater risk of flea beetle injury is when it sits too long in the seedling stage. And I always tell agronomists and producers, remember the numbers 3 to 4. Once the plants get to the 3 to 4 leaf stage, they are more tolerant to the feeding. And the seed treatments on your plants, they last roughly 3 to 4 weeks. So if you can get your canola, if the canola can get from the day of seeding to the 3 to 4 leaf stage in 3 to 4 weeks, you probably won't have to do foliar spraying. But it's when the canola takes longer than 3 to 4 weeks to get to that 3 to 4 leaf stage that your risk goes up. And last year, what happened, in some areas at least, we had good enough growing conditions that the canola was able to get off to that good start. Soil moisture was pretty good, and we actually had a very warm, if not hot, late May and June, so that the heat was there, and in a lot of areas that had good soil moisture, they were able to get the plants into that more tolerant stages before the flea beetles could do excess damage. So a big part of flea beetle risk is how quickly are things getting through that seedling stage. This slide up here is showing flea beetle damage. So the middle line here is roughly your economic threshold. So when you're trying to make that decision, do I need to do a foliar spray or not? A resource like that might be helpful. I've added this set of images to our flea beetle fact sheet. That was revised this past year, and it's got these images. So when you're trying to figure out, okay, do I need to do a foliar spray? Again, you can refer to this if you want. When things start to look like in this middle row here, that's a good time if you still have lots of flea beetles, you've got good feeding weather, that's the staging where you would want to consider doing that foliar spray. There's other factors to consider, but I don't have time in this presentation to get to those, but I'll be talking about those more at some of the other shows this winter. And you can call me or ask in the question period too. So grasshoppers is the next one I'll cover. Grasshoppers, again, were an issue in all our agricultural regions. Some people were spraying, some didn't need to. It was really variable within a region, but they were an issue in all of our different regions. And now, when we talk about grasshoppers, there's roughly 85 species in Manitoba, and we've got 4 we consider pest species or potential pest species. And last year, the one on your upper right here in the picture, the two-striped grasshopper, that was by far our dominant species. It's a generalist. It'll feed on a lot of things, so they will move from crop to crop as things mature. The other one we saw a fair amount of was the one on your upper right, the clear-winged grasshopper. That one is a grass specialist, so they will only feed on things like cereal crops, forage grasses. You often see them in big, huge groups or numbers, but they tend to be more localized. There were some areas in the southern Interlake and the central region where we had some higher levels. The Austin area, there was a few fields that had some very high levels of clearwing. But in a case like that, again, it's more your cereal crops, forage grasses you have to watch. They won't attack broadleaf crops. And as a side note, I have had people call me before and say they had a lot of grasshoppers. One instance, it was in a canola crop. They said, the field is loaded with grasshoppers, but they don't seem to be feeding. What's going on? And they sent in a photo. It was clear-winged grasshopper. In a couple of days, they had cleared out. What had happened was there was a pasture next door that had dried down. This was a couple years ago. They had moved from the pasture into the canola, realized this isn't food for us, kept on moving. So sometimes it's good to know what species you're dealing with. And as far as forecasting what is going to happen next year, now with grasshoppers, it's really tricky doing this forecasting. What we do is we do a survey in August. We count numbers along field edges and ditches, and we put together a map. So here's the map, a few areas of yellow and orange, which are where the high counts were. Nothing was terribly high, but we did have some areas that, well, even venture into that severe range. But my caution is we did have spraying for grasshoppers in all our agricultural regions. So for the people, say, up in the Interlake, if you're in maybe one of these green zones here, I wouldn't be complacent. It just happens that the counts we did in the ditches in those areas weren't in the higher zones. But based on what happened last year and the fact that weather conditions, we had really good egg-laying conditions. September was on average 3 degrees warmer than normal and very little precipitation. Great egg-laying conditions for grasshoppers. The first frost didn't happen until well into October. So our pest species, one of the things that makes them pest species is they can lay a lot of eggs, and they usually keep on doing that till a frost or something kills them off. So they probably had the opportunity to lay their maximum number of eggs. And so what happens when we get a warm fall is those eggs actually start developing. They don't turn into nymphs, but there is what we call embryonic development. So the eggs are developing, which means next spring they may hatch a bit quicker than if we had less embryonic development. So we had good conditions for that, for the eggs to move along. Some people might be wondering, well, now that we're into our -30s weather, will this kill the grasshopper eggs? And the short answer here is probably not. because it needs to get to about -15 where the eggs are for them to get killed. And even a little bit of snow is usually enough insulation that generally doesn't happen. You probably don't want the grasshopper eggs to get killed in the sense that if the grasshopper eggs are getting killed, probably your winter cereals aren't going to do too well. Because when it gets -15, 5-6 centimeters down, that's usually not a good thing. So don't count on a lot of winter kill. And as far as the spring goes, if we get an early spring, warm weather, we could start seeing a bit of earlier hatch. And just the last thing regarding weather I'll throw out, I always get people asking in the spring, when my ditches are flooded, will that kill the grasshopper eggs? Short answer is no. A colleague of mine did an experiment one time where he took grasshopper eggs, put them in a glass of water for a week, dumped the water out, and the eggs hatched. So they've got little waxy coating on the eggs called a corian that makes them a bit, it's like your Gore-Tex coat. It lets the eggs breathe, but water doesn't go through. So they're well resistant to excess water. So number 3 on my top 3 of the year was armyworms. So armyworms are an insect that doesn't overwinter here. They migrate in. It's a purposeful migration, kind of like your monarch butterfly. They actually purposely are migrating north. In most years when we get issues with them, it's very localized. It might be, say, the eastern part of the province or the interlake. Last year, they were right across the province. We had a big migration come in, and it kind of extended right into Saskatchewan as well. And it went as far north as the Pas even. There were people in the Pas finding armyworms. So it was a big migration, all our agricultural regions. Now, when I use the word armyworm, I'm not talking Bertha armyworm. That overwinters here. It's a whole different insect. This is sometimes called cereal armyworm or true armyworm or just armyworm. They prefer cereal crops. They will feed on broadleaf crops once they've devoured the cereals in an area usually, but when they arrive in an area and they're laying eggs, they're looking for a nice, thick, grassy stand to lay their eggs into. So winter cereals, forage grasses, pasture grasses, that's where we tend to see the most. And just, if you're wondering how this differs than Bertha armyworm, Bertha can have multicolors, so can this one, but a few defining features. They have this kind of brown, white, and orangey striping on the side. They've got a V on their head capsule, looks like a brown V, and on the back legs, they have what look like little bands on their fleshy little back legs that they hold on to the plants with. So that's armyworms. And the other thing we did see last year was later in July, people were sending in photos of these clusters up on the cereal heads, wondering, are these the armyworm eggs? And short answer, no. These are a good thing. These are pupa cases of a parasitic wasp called Cotesia. And what happens here is Cotesia, this is the Cotesia wasp here, they will lay eggs into the armyworm caterpillars, but they never lay just one egg. It's usually dozens of eggs into a single caterpillar, and the eggs are all the same age. The wasp larvae grow inside the caterpillar, eventually kill it, and almost simultaneously you get this cluster of wasp larvae that emerges from the armyworm, and very, very quickly they form these pupa cases up on the cereal heads. So if you're seeing a lot of that late in the season, that's Cotesia, good thing. It means you'll have less of a second generation of your armyworms, which was the case. So 5 or 10 more, Lionel? Or okay, 5 more. So, okay, so one of the questions I had, well, one of the questions Lionel got was aphids. Are we seeing more of them? And do the same species attack different crops? Short answer is most of our aphid species that we deal with blow in. So it varies greatly from year to year. It's very hard to predict. And regarding species, we have different species on most of our different crops. So the one you see in your cereals is usually either English grain aphid, this one here, or this smaller, darker oat birdcherry aphid. Again, neither of these overwinter here. They blow in. It's not a migration. They get blown in. Those are the two you see in your cereals. On your soybeans, it's soybean aphid. In your peas, it's pea aphid. In flax, it's potato aphid. So you do have different ones in different crops. Last year, we had a fairly heavy aphid population in our small grains. There was some spraying going on. There was lots of natural enemies. I think Anastasia might be covering it, but in some of the fields, the natural enemies actually did a very good job of taking what were economic populations and dropping them to very low levels. So we did have some good natural enemy activity happening, including, these are aphid mummies. So these are hollowed out corpses of aphids after a parasitic wasp, in this case called a Phidias, laid eggs into them and developed inside them. I'm going to skip through that just so I can get to my last insect, lygus bugs. So lygus bugs, locally abundant. Lygus bugs are a sap feeder. They don't chew plants. They put their beak in and they suck the sap out. They feed on many things. They like the newest growth, so they like flowers, buds, and young seeds. Once the seeds harden up, they usually stop feeding on them and move to somewhere else, but they like those young seeds, so they can be an issue in things like canola, dry beans, alfalfa seed, sunflower seeds, a lot of different crops. And we did have some economic levels last year. For anybody scouting canola or growing canola, do note that the economic threshold for lygus in canola has been updated. We're no longer using that 10 to 15 and 10 sweeps. That was done when canola was this tall and on some of the much older varieties. So they redid the economic threshold work with modern varieties, and this is what they came up with. Generally 20 to 30 per 10 sweeps. In good growing conditions, use 30 per 10 sweeps. If it's really dry, drought stressed, probably the 20 is a better threshold to use. And that is, as you can see, quite current. Hector Carcamo was involved in that study. It just came out like a month or so ago. So very current stuff. Somebody was asking about pea leaf weevil. Pea leaf weevil, it's a weevil that it was first found here in 2019, relatively new. We've been tracking populations of it. The actual weevil that you see here doesn't really do much damage. It'll make little notches on the leaves. It doesn't do a lot of damage. The larva feeds on the nodules of peas and faba beans, not the roots, the nodules. So if you have too many of them feeding, you get less nitrogen fixation, and then you get a nitrogen problem. And we've been tracking pea leaf weevil numbers for a few years now. Last year, here's what our map looked like. So anything in yellow and orange was higher levels, and you can see this Dauphin over to Roblin area up to Swan River. That seems to be a hot spot, so numbers were quite high there, and I know some of the people there were considering seed treatments as a possible way of just managing the pea leaf weevil numbers. And I'm just going to end off by mentioning stored grain insects. That was one of the questions. I've put two of them up here. Rusty grain beetle feeds on the grain. Foreign grain beetle feeds on the molds in your bin. I would encourage people, scout your bins, know what's in there, maybe every couple weeks over the winter. If you have stored grain beetles, turn the aeration on. Now's a good time to do that. They'll be dead once you get that grain cold enough. And if you don't have aeration, move the grain. Just move it to another bin, or move it to a truck, let it sit, move it back in, and that should help. And as an FYI, there is a stored grain insect survey going on. Vincent Hervé with Agriculture and Agri-Food Canada is doing it. I'm helping Vincent find cooperative farmers for this. If you're interested in having somebody come and put a couple bins in one of your traps in the fall, they would be removed 2 weeks later. You'd get a report on what beetles are in your bins, and Vincent would get good information on what is being found in Manitoba bins. If you're interested in that, either contact me, let me know, or I do have a sheet with me after the presentations. You could come and I could get you signed up for that. So I'll maybe end with that, and we'll turn it over to Kim.
Can I walk? Can I use this one? Can I walk around?
Just turn.
Thanks very much. Okay, so thanks very much, Lionel, for having us here, and thank you guys for all taking your time. I have a shout out to our colleague, Dennis Lang. He's our pulse specialist, well known for his Hawaiian shirts, and he's discovered a place that you can take pictures and put them on Hawaiian shirts, so I am wearing a water hemp shirt today. So if anybody's interested in it, just talk to Dennis, and you can probably put anything you want on a shirt, and so Dennis has given me a water hemp shirt, because that's my life these days. Anyways, 2023 in review, generally, we had some challenging spray conditions. It was hot, it was dry, it was windy. Things were not, it was a very difficult time, but actually, in retrospect, things worked out fairly well. We generally had good weed control, and so things worked out fairly well. What we did have a problem, though, is that because we were so dry early on, we didn't get a lot of weeds come up in crop normally, not as many as we normally have, and so those late season rains that some of us got more than others, but those late season rains caused weed flushes, and so our C4 or our warm season weeds, like our pigweeds, our foxtail, our barnyard grass, our kochia, those things came up when we started getting those rains. And even our cool season weeds came up later, anywhere where there was bare spots in the crop, so cedar skips or thin crops, or maybe there wasn't really drowned out areas this year, but anywhere where there was any bare ground, and there's lots and lots of weed seeds in the ground, so those late season rains or those late flushes caused a lot of late season weed growth, and by then it's far too late to be doing anything about it. We just kind of have to live with it, and that's where we have to, work up front at getting really competitive crops, getting really good growth, covering the ground early, and that type of thing, and that'll help with that when those things happen. So herbicide-resistant weeds in the West, today I'm going to talk to you quickly about kochia. There's also wild oats and downy brome. Downy brome is significant. That's our first glyphosate-resistant grass in the West, in Western Canada. There's a glyphosate-resistant grass in Eastern Canada. Hopefully we don't get that one here. Also water hemp and Palmer amaranth, which for some of us is becoming more of an issue. And then also coming soon, Canada fleabane. So kochia, we all know and hate kochia. On our last abundance survey, it showed up as number 12. In the province. That was our survey that was done last summer. And so this is a weed. There's, for conformations of herbicide-resistant kochia, up here, group 5 resistant kochia was found as far back as 1976. There's some people in the room that weren't born then. And so our group 2 resistant kochia in 1987, North Dakota and Kansas, in 1988 in Manitoba and Saskatchewan. That was the year after I graduated from high school. So basically, all the kochia in the province has been group 2 resistant for a very, very long time. In group 4 resistant, 1994 in Montana, 2015 in Saskatchewan, so we're starting to see some group 4 resistant kochia. That's significant. I'm going to talk about that in a minute, because we've been relying heavily on dicamba and fluroxypyr, whatever products those are in, to control our kochia, because we know our group 2s don't cut it. And then our group 9 resistance, that's our glyphosate. So 2007, that's actually a fairly long time ago in Kansas, 2011 in Alberta, and shortly after that in Manitoba and Saskatchewan. And now this is new. So this is what I'm going to concentrate on today, PPO inhibitors. That's group 14 chemistry. So this is a group that we've been using for a while. We're starting to get more and more products in this group, but we're not getting any new groups. But there are some new products in this group. So in 2022 in North Dakota, 2021 in Saskatchewan. And so these are products, this is what I'm going to talk about in a bit. So group 14 resistant in kochia. So I want to talk to you about these slides. This is saflufenicil, which is heat. And so this rate here in the red, that's normally what you guys would be spraying in crop. Not in crop, but it's a burn off, right? So normally these two populations in the front, they're susceptible 1, susceptible 2, so it's still working, they're dying, it's even dying way back here at this rate, but this resistant population in the back, it's labeled with an R, so it's resistant, so a field rate's not going to hurt it at all, triple the field rate doesn't hurt it, 10 times the field rate still doesn't kill it. So if you'll notice these numbers along the bottom, this is not a linear scale. So this is 25 grams active per hectare. This is 79. That's over 3 times as much. That's 10 times as much. Here's 100 times as much. So the problem with resistance for the group 14s is that it seems to be coming on pretty fast. When it comes on, these products really aren't working. When we're looking at something like AIM, this is carfentrazone, and this is this is AIM. This is the field rate here, that's that 30 mil an acre rate, that's 17.5 grams active per hectare. Our susceptible population, 1 and 2, and then here's resistant along the back. And you can see this resistant population, there are extremely high rates of AIM, and it's still not killing that kochia. So this was from a population in Saskatchewan. So far, just one population in Saskatchewan where not just these group 14s just weren't working anymore, and they are really not working. When we look at, this is Ultra Blazer, not used commonly, but it's a different kind of a group 14, so still a group 14, but within all of the chemical groups, there's different families. And so we've got, actually, this is our field rate here. Even our resistant population is working. This is significant, not that we've tested Reflex, but Reflex is in this group. So any of you guys that are using Reflex, that bodes well for that right now. This is Authority, and we're finding this is on a clay loam soil, so we know this is a soil-applied herbicide. Well, it works on the weed seeds as they emerge, so we use this one pre. And so this is our field right here in the middle. These are 2 susceptible populations. This resistant population in the back, it's just not dying. And even at twice that, it's still not dying. It's been hurt a little bit, but it's not dying. So at twice the field rates, Authority in a clay loam soil is not working. There is a bit of an interaction here with different soils. The sandy loam soil, the sulfentrazone or the Authority, it actually worked a little bit better. So, but that's something that, that has to be teased out. There's also a pH effect with Authority as well. So there's lots of things going on here. Either way, we do know that we are starting to see, here's the field rate here, and it's definitely, this kochia is smaller than these other plants, but it's still not dead. And so we want to see things dead at the field rates or we start to have problems. So kochia control or suppression, basically, we basically assume all kochia in Manitoba's group 9 resistant, so we haven't had that tested. You can still get it tested at the PSI lab in Winnipeg, and I would assume it's all resistant. My take on it, I'm thinking 85 to 90% of it is, so I think you should assume it's resistant unless you absolutely know it's not. So we know glyphosate's not working on kochia anymore or working in very few places. What else can we use? So in the crops that we can use it, we can still use our group 3s, which is Edge. We can still use our group 4s if they're still working, dicamba, fluroxapyr. Group 6 is Pardner, which is bromoxynil, but it's also in other products. Group 10 is Liberty, which is, for Liberty-tolerant crops. Group 14, Authority and Heat. Group 27, which is Infinity on deck. That's a new product from Corteva. That's very similar to Infinity. It's a group 27 with a group 6 in there as well. Also your corn herbicides, your Lotus or your Armazon Impact. And then we do have suppression in group 15, which is Zidua, and it's this pyroxasulfone that's also found in Fierce and Focus. So, but, and this is a big but, there is growing group 4 resistance. I didn't have time to show you some of the slides, but we've got growing group 4 resistance. It's coming on fairly slowly, but it's definitely there. So we know we've got places that group 4s are starting to not work on kochia anymore, so our dicamba and our fluroxapyr are starting to fail. And we also have group 14 resistance as well. So if we lose our group 14 and group 4, then all of a sudden we have group 3, group 6, group 10, group 27, and some suppression of group 15. So then we are rapidly running out of options for kochia. So this is significant. So I want everybody to be aware of this group 14 resistance. It's only one population found in Saskatchewan so far, but several populations in North Dakota. And so any of you who took in the MAC conference, we had Dr. Brian Jenks up from North Dakota talking about kochia resistance. He talked about this very subject. They have multiple sites where this is going on in North Dakota. So the MAC videos or the talks are recorded, and you should be able to watch those. And so you could search for that one, search for Brian Jenks's talk, and he'll talk about the same thing in North Dakota. So talking about water hemp quickly, and again, I have it on my shirt today. This is water hemp and Palmer amaranth. These are tier 1 weeds that are regulated under the Noxious Weeds Act. They must be destroyed when found, so either hand pulling or mowing when we find them, and we're far too late to control them chemically. They must not be allowed to set seed as they're prolific seed producers. The big plants, like the ones you see, the one we saw in the picture, the ones that are on my shirt there, this is actually from our latest Seed Manitoba. We've had an article about water hemp last year and another article again this year. Some of those great big plants, those are millions of seeds on those plants, and they are all resistant. When we have chemistry or chemical resistance showing up, or herbicide resistance showing up in all of our weeds, normally we've done that to ourselves because we've overused chemistries, we haven't rotated away from them enough, and so we cause this herbicide resistance ourselves. This water hemp is coming to our door, it's coming to our border, it's preloaded with resistance. It's already resistant when it gets here. This is something that isn't here, and when it shows up, it's already resistant. So Most of it that we have found, but not all, has been found in soybean fields where glyphosate is the only product that's been used. And so last year we found it in multiple Xtend soybean fields where the dicamba hadn't been used. We know in other places in the world dicamba is failing with water hemp, but we don't know that yet. We think right for now it'll still work well in Manitoba again, but the glyphosate is not working. So this is what normally we see. This is a nice looking soybean field, and you'll see this field that is as tall as me or taller, and all of a sudden you know there's something that's not right. And then, so this is an older picture. This is actually my 2022 weed control guide for comparison. This is our boardroom tables in Carmen. These are 6-foot-long tables. This is a weed found late July in a field near Carmen. It was a soybean field sprayed with nothing but glyphosate. So when you see a weed that's over 8 feet tall in your field, you know you've got a problem. And just wanted to point out, it does look like a really, really big pigweed, but the tops on them are kind of long and snaky. They're very different looking than a red root pigweed. And you know, we've got lots of talks going on this winter about how to tell what the difference between the pigweeds and that, so hopefully you can take in some of that information at one of my talks elsewhere this winter. But we do find it in other crops as well. This is it in a wheat field. This is you know, just germinating, just a little guy just going. And then here, this is a soybean field, and all of this back here is water hemp. This is all water hemp. This guy had to mow down several acres of his crop. It was actually solid water hemp in there. So what to do when we have water hemp? Initial testing results indicate that it's a good chance of already being resistant. It's resistant to combinations of 2, 9, and 14, sometimes all 3. It doesn't appear to be a problem in competitive crops like wheat and canola. Now the exception would be Clearfield canola and Roundup Ready canola, obviously, because it's group 2 resistant and it's group 9 resistant. So in those cases you need to be putting an edge down first. Serious problem in corn, dry beans, sunflowers, and soybeans, and mostly because these are row crops. These are crops that the soybeans can be grown in narrow rows, but it's especially bad when they're in wide rows. These are wide row crops. There's lots of bare ground. This is a weed that likes high light intensity. It likes lots of heat. It's a warm season weed. And so in our row crops, it takes a long time for some of those rows to close in. And so this weed can just take off in those. This weed just has ample opportunity to get going in those crops. So in our really competitive crops, like again, our wheat and our canola, or our cereals and our canola, if they get up and going and they cover the ground, they'll actually smother out this weed, and lots of times it won't even germinate. Herbicide, we need to do herbicide layering to get the weeds out early, especially when the crop is non-competitive on those row crops, and because your in-crop options become limited or actually non-existent. If you just had a regular Roundup Ready soybean that wasn't an Xtend or an Enlist bean, and you ended up with water hemp in it, you have 0 options that will control this weed. So this is the latest map of Manitoba. This is anything in red is where we have DNA confirmed water hemp found in Manitoba. This is on our website, so if anybody wants that, it's easy to find. Basically, it just keeps getting redder and redder, and we're moving a little bit further west, and we've got a couple places up here in the north along the Saskatchewan border here, and then up here in Dauphin, we've had a little bit of water hemp found up there as well. So this is my last couple of slides. Canada fleabane or horseweed, this is what I call I think this is our next bad news story. I've been watching this thing for 20 years because it's been a problem elsewhere for a very long time, and it really hasn't been a problem here. We've got Canada fleabane around. It was up until recently, it's kind of just been lurking on the edge of the fields. It's kind of in under the trees, and but it never really came onto our fields much. But this last year or two, we've had a lot of reports of farmers finding it right all throughout their field. So far, our chemistry has been working. We haven't had any issues with it. I've had a couple of reports where they thought it was maybe glyphosate resistant, where maybe 1 or 2 plants escaped. We weren't really able to confirm that, but we are watching for that. And the reason is, I'll go through the biology first. So it starts off as a rosette. It's really hairy. Sometimes it's really rounded on the edges here, but it always has these little backward pointing notches right there. Most times, though, it's a bit more pointy ended on the leaves. It looks more like this. In this case, it kind of looks like stinkweed, but it's hairy and it doesn't have that smell. But it always starts off as a rosette. Usually, though, it looks a bit more like this, and then all of a sudden it bolts. It won't have any tillers on it. It'll just be one stem unless it got sprayed or unless it got mowed and the growing point was affected. But this is what it looks like in soybeans. This is a picture from Ontario, and this is wide row soybeans, and this is solid Canada fleabane in between. And the reason that we're concerned about it is that in Ontario, we've got group 9 resistance in they found that in 2010, and they now have group 2 resistance as well. But elsewhere in the world, in North Dakota and other places, there are biotypes of this weed that actually are group 2, 3, 6, 8, which is now a 15, 9, 14, 15, and 27, either resistant or tolerant. So it becomes a very bad weed very quickly. So I think I just want everybody to be aware of that and really watch for that. And if you have any concerns, if you are suspecting anything with kochia, some group 14 resistance or any other resistance you're concerned about in kochia, besides, obviously glyphosate in group 2, and then also Canada fleabane, if you've got some concerns about this, please let me know, because we need to investigate this and kind of, see where we're at. So with that, I can hand it over to David, and I know Lionel had some questions for us, but we can answer them at the end, right? Okay. Do you want on here?
I don't know what will work best, whether I, like Kim, hold this and walk around. Maybe we'll try that. So Kim mentioned just a moment ago that she is sometimes the bearer of bad news. A lot of times she is that. And so collectively, we each have our formal titles, but you could call the three of us here the bad news bearers if you wanted to. And we also have some short names. I'm the field crop pathologist, John is the entomologist, Kim is the weed specialist, but John sometimes goes by the shorthand of the bug guy, and Kim now is being known as the scary weed lady. You have to be careful of the emphasis there. Not that she's a weed lady, she is a scary weed lady. And because they're all wearing shirts, I've got on my fun guy shirt, because many of the plant pathogens, the diseases that we talk about, are caused by fungi. Okay, all joking aside, I'm going to talk briefly about what we saw in 2023 and talk about the prospects for 2024. It turns out I'm a failure when it comes to predictions. I might show you that later on. What's going on? Oh, my screen's not up. I have to advance it. See, I'm not technologically adept. Okay, there we are. That's what I'm going to talk about today. So, the growing season events that led to what we saw in 2023. It was a pretty hot, dry year, as it's been said already, but we started off with quite decent soil moisture, so that was good for crops. It held them on to the end of the season in many cases. We had a cool, dry spring, and seeding was generally uninterrupted, so we didn't have these gaps that we had like in 2021, where we had 2 different stages of crops. But we had this continental rainfall pattern, which is where you get showers here and not next door. There were no general rains. They were all spotty. And so you might have had a disease issue in your crop and your neighbor didn't. And it might just be because of variations in moisture. But it was generally dry through much of the growing season, June, July, and August, with above average temperatures, quite warm in fact, and these are not disease-conducive conditions. So at one of the field days I was at, I was saying it's really a non-disease year, and perhaps global warming is going to put me out of business. That is a joke. There'll always be a place for a plant pathologist. What are we looking at for 2024? Well, this is a map that's just come out from our ag meteorology group, and it shows the soil moisture as of just before freezing in the fall. And this is from the 120 weather stations that we have across the country. It's at the 5 centimeter depth, which is equal to about 2 inches or planting depth. So that's a measuring stick. It's not a take it to the bank kind of how much moisture you're going to have in the spring, but it does tell us that though it seemed kind of a dry, open fall, and it looked like we weren't going to get a lot of snow, there is moisture there, and now that we've got snow, it's probably going to hold it in the soil. That's enough about weather. So now I'm going to jump to a bunch of questions that Lionel gave me before from producers. And one of those was, where are we at with clubroot? Maybe we haven't been hearing a lot about it recently. Well, we do a general canola disease survey, and in that survey, we find canola in the 130 fields we look at maybe once every 3 years. And this year we did have one new symptomatic case. It was up in the Northwest in an RM where we've seen the disease before, and it's an area where they're really abusing rotation, if I can be so blunt. They're probably growing canola 60 or 70% of the time, 2 out of 3 years. So it's not surprising we see a disease like canola rearing its ugly head when we pull it out of the ground in places like that. There were also 40 soil samples taken this season. Those are going through the PSI lab in Winnipeg. Those results are still pending. But the map that we use to show distribution, we actually have 2 different styles of maps. And that's the one we have been using for quite a few years. The red ones are places, RMs, where we have had symptomatic plants. The other ones, green, yellow, and orange, are really just indicating that clubroot is there in the soil and at various concentrations. The orange ones are fairly high concentrations of spores, but we haven't yet seen symptoms. Problem is that Saskatchewan, a couple of years ago, came out with a map that shows similar distribution, but uses a different color scheme. And maybe it's a wiser, simpler color scheme. You don't have to worry about us men who might be red-green colorblind. It's just 3 levels, and it's their orange ones that show where symptomatic cases have been found. And so in Manitoba, we adopted the same style, and it shows you then how things are across the border. I'm going to have to back up a little bit and say that the orange RMs in Saskatchewan are the ones where they've had 10 or more symptomatic cases already. The yellow ones are where there have been up to 9 symptomatic cases, and the blue ones are where clubroot's been detected in the soil, but not yet any symptomatic cases. Which diseases are important in canola? I mentioned we survey every year and look at about 130 fields. We're always looking at blackleg. Sclerotinia can be a concern in wetter years. Clubroot's always on the radar, and I don't know why that's now hidden, but verticillium wilt, actually verticillium stripe is what we now call it, is one that may be of growing importance. Another question that came in was, I'm a new sunflower grower, and will I be using fungicides on my crop? And before I get into this, I'm glad I conferred with Anastasia, a colleague who was my boss, and is also a grower and grows sunflowers. So she has some experience in this and has said they have only used fungicides maybe twice in 10 years? 8 out of 10 years. Okay, maybe I'll get her to explain that when she comes up here. But they're using fungicides for a different reason than what I'm talking about here. I talk about sclerotinia because it's really troublesome in sunflowers. It can attack the crop at two different ways and at 3 different times. It can go straight into the root and cause the whole plant to flop over. And with spores, with the aid of spores, it can cause mid-stalk rot and head rot. And it's head rot that's really going to cut into yield if it's there. You probably won't be able to deal with it by use of fungicides. All those that are registered give suppression only. And there are some ideas of what they are. They have drastically different pre-harvest intervals, and especially with confectionaries, you have to be conscious of that. You probably have to talk to your buyer to know whether or not a fungicide is even permissible in the production of that crop. Somebody also asked about a new sensor for detecting sclerotinia spores in the air around susceptible crops, which include canola, beans, sunflowers, virtually any of the broadleaf crops. And I don't know of something that is a black box that you can just put it out in the field and it sends a signal to you saying, oops, there's a lot of ascospores in the air, you better start thinking about a fungicide. To my knowledge, there is nothing like that. There are various types of spore traps, and this is a scientific one that we have used in the field. It actually is a drawing physically, or I don't know how to describe it. It's sucking air into the trap and depositing it into little vials in which we can measure the number of spores that are present. But it's not an instantaneous reading. You have to take those back to the lab and determine. So still, the best methods for looking at Sclerotinia risk, for example, in a canola crop, is have you got a really lush crop that's going to yield and is worth spraying in the first place? When you walk through it early in the day, are your pants wet? And that indicates that the soil beneath is staying moist. The conditions where the little spore-producing structures, apothecia, might be found. And okay, in these last couple of years, it's been quite a debate whether or not I'm going to use a fungicide in canola, because, okay, I've got a decent-looking crop coming, but it is dry in there. There really isn't a chance for infection to happen. It relies on free moisture for 48 hours on the plant, and also the spores to be blowing around and infecting the petals in that crop. Another question was, can flea beetle injury actually make diseases like blackleg worse? And I'd have to say I don't know. I do know that blackleg has its greatest potential impact when it is attacking the crop at the cotyledon or first leaf stages. Then it can work its way into the stem and cause that whole plant to die, a little bit later in the season usually. The infection that happens later probably isn't so important, but the fact that it can infect at that seedling stage, the same time when flea beetles are feeding, it actually can get into the plants easier when there are physical wounds, which flea beetles cause. But John will probably tell us that flea beetle feeds, and soon that leaf is reacting, and there is a process called suberization, or healing over, so that wound doesn't stay open for very long. And I think it would be kind of a tenuous connection between flea beetle feeding and intensifying blackleg infection. Sclerotinia infection happens much later in the season, so I can't see any connection there. Another producer said, we grew lentils years ago. They pretty well left the province because of diseases that we encounter. But now there are new fungicides to deal with those diseases. And does that mean that lentils will come back to Manitoba? I'm skeptical. There are 3 pathogens or major diseases in lentils. Anthracnose and Ascochyta are the 2 foliar ones, the leaf diseases that pushed lentil production out of Manitoba, because traditionally we're the eastern prairies, we are wetter, and so lentils migrated into the drier parts of the prairies. Aphanomyces is a root rot, and that also is troublesome. It has a range, a host range that includes a number of pulse crops. We're probably most concerned about it in field peas as they become more important here. There are foliar fungicides, yes, for the first 2 diseases that we mentioned there. And there are some seed treatments that are supposed to give suppression of Aphanomyces. But having fungicides available is not suddenly going to make it easy to grow lentils in Manitoba. There have been advances made in resistance to particularly Ascochyta, but those you'll have to check your seed guides to know the resistance levels. Okay, where are we at? This was an oddball thing. How many of you, when you're harvesting canola, saw this grayish-white powder blooming out of the combines and getting stuck on the equipment? Show of hands. 1, 2, 3, 4, 5, 6. Okay, we saw some of this. You see that swather there that is coated in 1 or 2 inches thick of powdery mildew spores. What is that, and where did it come from, and does it impact yield? Well, it is a fungal disease. It thrives in dew-forming conditions, which are generally hot, dry days and cool nights. And it seems to affect our crops quite late in the season. So the growth is a little bit superficial. You might find it on a late maturing crop, so one that was seeded late and is now maturing late. That's where it's most likely to be. Because it's arriving late, we don't feel that this has a major impact on yield. I'll leave the questions for later. You can ask me why I have a picture of a bear. I think it's time to turn it over to Anastasia.
Thank you, David. Hi, I'm Anastasia Kubinec. I'm an agronomist with Paterson out of Holland. As Lionel said too, I also farm. So the slides that I have, oh, there's a few more here, David. Can I just fast forward? There you go. I also farm at Holland. So some of the observations that I'm going to talk about are ones that I saw on my own farm, but with the clients that I work with, as well as I work with quite a few other agronomists, because from what I learned working in many years in Manitoba agriculture is if you don't know the answer, talk to others, because chances are they probably do, and then that makes you more effective with what you're doing. So I'm just going to go over quickly some of the things that I saw. I have a few pictures to share, and then I'll cover some of the questions that Lionel had presented to us before. So one of the big things that I saw this year, as Kim mentioned, early on the weed control was fairly good in the crop, but what we saw later on in the season was a lot of breakthrough in crops. And she kind of went over the reasons. We had some poor emergence, or in my area, we had a lot of very short crops, like when wheat's not even hitting your knees, I consider that short. And then we had some July rains. So that combination of maybe a few less plants, not as competitive crops in the field, not covering that ground, those late rains, we did have a lot of those later season weeds kind of break through. Some of the biggest crops that they broke through in, sunflowers, as I have the picture here of a bunch of green and yellow foxtail coming through the sunflower canopy, so row crops. Really uncompetitive crops like peas and flax. We were having a lot of barnyard grass break through, and I was seeing a lot of green and yellow foxtail breaking through in soybean crops later on in the season. Pigweed as well, and then of course kochia, but living in Holland, we just kind of have a, you know, every year is a kochia year for us. On the insect point of view, I have a few pictures up here. As John said, flea beetles maybe weren't as big of an issue this year. Really, in the region that I'm in, we probably, you know, in 2022, there was probably 10,000 acres that were sprayed for flea beetles in canola. This year was probably less than 1,000. So it was there, but definitely not the issue that we saw in the past. Grasshoppers, again, though, were quite a large issue. There was a bit of spraying that was happening kind of right before heading in wheat. There was a lot of damage to our wheat crops. And the thresholds definitely were there. You'd walk into the field and it was looked like the parting of the Red Sea as you walked through the field. There were so many grasshoppers. We did get some fairly good control on the grasshoppers. The picture in the bottom here was actually shared with me by a client. He said he was walking around the field and noticed along the edges here he had really poor crop emergence and was concerned that maybe there was some compaction there, the crop wasn't coming up. He actually had somebody take a drone out, and then we investigated further, and this is all grasshopper damage. The grasshoppers were coming in from the edges of the field and completely decimated the edges of the field, and the crop had come up, and the grasshoppers just ate it off. So definitely a good indication that maybe it needs to be sprayed to protect the rest of the field. And then after that spray, he did not need to spray again for grasshoppers. It held them off. Very effective. Other issues that we saw here were armyworms. In our area, we again did have some fields that were sprayed for cereal armyworms in wheat. We did do a lot of investigation though, checking numbers. We also were looking for a lot of the parasites here. We had a nice crispy little armyworm. I had a better picture of the Cotesia kind of growing out of the armyworm, but it wasn't as clear as this one. as well as we did have a lot of aphid issues, both in oats and wheat. And as John mentioned, we did have one field where you would walk into the field and it was like you had like waxed pants coming off out of the field, that the honeydew coming off of those aphids was so thick. After watching it for a couple days, though, it was quite incredible, the increase that you could see in the ladybugs and a lot of the other beneficial pests. And after about 3 days, 4 days of walking the field, there was no aphids. It had dropped. The population had completely crashed. So that is one thing that I see as an agronomist too, you know, walking into the field or having a farmer calling you with like that stress of, oh my gosh, like look at all these insects in my field, we need to spray immediately. Going in and walking in and doing that count for the beneficials as well as what the pests are there is really important. One app that I use that's great for that is the Ag Canada Aphid app that you can get on your phone. You do have to be patient in the field because it asks a lot of questions, but it is very effective with helping you try to determine whether or not you do have enough beneficials in the field to actually take care of your aphid population. Another one that I wanted to talk about here is a misdiagnosis of wheat stem sawfly and wheat stem maggot. I probably had 3 or 4 farmers call in and say that they figured they had wheat sawfly, which is not really an insect that we see in Manitoba, and I just wanted to go over it quickly. Sawfly damage, this is actually a picture out of the States, and then this is a picture that a colleague had shared with me with wheat stem maggot. So I have seen sawfly damage mostly in Saskatchewan and Alberta in a previous life. And just think of hail damage or somebody took a flail mower through your wheat crop. That's kind of what you're going to see. And then you're going to see at the bottom here where you actually do have that actual feeding damage on it. With wheat stem maggot, it's 1 or 2 heads that you're going to see that are completely white. And then when you take the head, you can pull the head out very easily. It's not cutting at the bottom of the stem. The whole plant is not dead. It is just that one single head coming out. So just something to, you know, understand looking at it. And unfortunately, the first thing when you Google it, you know, wheat heads dead in field, you're going to get sawfly pictures. So it's very easy if you're just going by Google. That's what you might come up with. Would you agree with that, John? Thanks. For disease, we did have some fusarium in our fields around the Holland area, and that was really because we had localized showers. In July long weekend, we had crop in stage. Working for Paterson, I also am attached to a grain elevator, so I do see a lot of grain samples that come through as well, and I am trying to learn more about what the grain samples are, what's seen in the field in crop, and then how that contributes to actual grain samples. So I do have to go out and take a look for fusarium, just to give the folks a head up, you know, coming into fall, are we going to have fusarium issues, and are we going to have to look for markets ahead of time? So fields that were not sprayed in the area, yes, there was kernels that were in the heads that were infected. Did that mean that we're having high fusarium numbers coming into the elevator? No, it doesn't. It was still quite low, but it was there. In the odd case where fields weren't sprayed or were sprayed very late, there was probably entire heads that were infected, but most of all in the sample, it's not coming up so bad that we're getting a sample grade or even a reduction to a grade 2. Everything still is coming in as a grade 1. In canola, powdery mildew is what David had talked about. Also sooty mold, which I'm going to show you a picture later. And that came kind of at the end of the season where we had that 10-day break because of that humid, wet weather. Verticillium stripe, we are seeing it quite a bit in the Holland area. We're seeing it post-harvest, so it's really hard to identify, in my point of view, when you're looking at it in the crop before you actually are combining it. It's not till that plant is completely dried down and then you can start to see the microsclerotia after harvest. And then blackleg and verticillium stripe are still being confused, so this is another one. So I just have some pictures up here. I'm guessing if I ask for a raise of hand, if anybody cuts their stems to look at see what the pith of the stem looks like, nobody's going to raise their hand, right? Yeah. So if you're going in the field, what you really want to look for here is this breaking away of the outer piece of the stem, kind of that skin of the stem, and then in between that, you're going to see this really tiny little dots. Versus blackleg, you don't need to do that. It's going to be right there kind of on that skin of the stem. You're going to see these raised little pepper pieces. So that's kind of how you tell apart between blackleg and verticillium if you're not going to cut through the stem. or go talk to your retail agronomist or agronomist that you work with, and they'll hopefully be able to identify it for you. Versus what else we saw this year was this sooty mold, and it was the entire plant was absolutely covered from soil to tip of this black mass. And we saw this in 2014 when I used to be the oilseed specialist, and then we saw it again this year. And it wasn't until we had that hot or warm, humid weather and harvest was kind of shut down for about 10 days in October, and this started showing up after that fact. So just kind of segueing into the delayed humid harvest and what that meant. Again, working in a grain elevator. Grain went into the bin dry, but the next 6 weeks with humid and warm air, if fans were being run, sometimes the grain wasn't drying down or wasn't cooling down what guys wanted to see. As well as lodged canola that was slow to dry down in combine. There was a lot of chaff and trash coming into the bin. So what we're seeing right now is we're having some issues with the grain coming into some of the elevators, especially in the elevator that I work with. So just a reminder that agronomy for agronomists and the staff and for farmers too, it doesn't stop when your field has been combined. You have to be monitoring that quality of that grain in the bin too to make sure you're getting the best quality to the elevator and you're getting paid for that. So since probably right after Christmas, in my elevator, we've had 16 Celsius canola come in, and it's had a little bit of heating to it. And the big thing with heating is you're going to notice first as a farmer when you're checking your bins is it's going to have a smell. If you are going to smell your canola, canola should just smell like grain. It really shouldn't smell like anything. But if you're kind of getting a slight little sour smell, that's going to give you a quick indication that maybe there's something going on in the bin. As Lionel had said, and now would be a great time to take a couple loads out of the bin, maybe turn your bin, turn the air on. If there is heat in the bin, it may be in the core of that bin. So putting that air on, taking that load out, you're maybe breaking up that hot spot, you're getting that cold air in there, you're freezing it, and hopefully you're killing if there's any sorts of mold starting. As well, we saw some 11 Celsius oats coming in, and it had rusty grain beetles in it and red flower beetles, and they were very actively alive. So again, for that farmer, he had come in with the sample. The recommendation was turn your fans on, freeze them out, and potentially use a grain vac when you're taking it out of the bin because that's going to kill some of those insects too. We don't want insects coming into the elevator, so if you do have a sample coming in, unfortunately it could be rejected very quickly. Upcoming, and this is my prediction from what I've seen in the past, crusting in peas and soybeans can be happening too. Typically you're going to start seeing that in February, and you're going to see that in the north side of the bins. It's not the peas and the soybeans itself, it's all that trash and pod pieces that have come into the bin with those peas, and they're going to be against the wall, they're going to be warming up in the nice sun, it's going to get wet, and you could potentially start getting some molding there too. Again, checking your bins, you're going to start getting that sour smell. So one of the questions that came into Lionel was sunflowers, and I just really quickly wanted to go over a few things. I do grow sunflowers. When I was the oilseed specialist, I dealt a lot with sunflowers. So some things to consider. There's two types of sunflowers. There's both your confections and your oil seeds, and they are very different. So confections, you get your premium pricing, but unfortunately we have limited buyers, and there's very few varieties that have herbicide tolerance. So if you're thinking, if you grew sunflowers 10 years ago and you're going to find some assert or mustard around, you're not. So you're probably limited to a really good pre-emerge and potentially some inter-row cultivation. So that's something to keep in mind with confections. Oils, on the other hand, there is quite a few varieties around with herbicide tolerance, both for like the Clearfield program and then the Express program, which are very effective. There are more markets and there are more buyers. The other question was equipment versus custom. With confection, you're best to plant it with a planter. You want to have that row spacing and less plants in the field because you're going to have a larger head size, and larger head size means larger seed size. With confects, as you're eating spits, you want the big spits. You don't want the little tiny ones. So that's what farmers are getting the premium pricing on. So for equipment, you probably need to have somebody with a row planter if you do not have one. If you are growing oils, you can solid seed them through your air seeder. That has been done very effectively. Seed size is still important, but not as important as the confects. So you can probably seed them yourself if you're just wanting to get into sunflowers. The big thing though with the sunflowers is you are going to need a header that's going to be able to combine those sunflowers. Your corn header is probably not going to work. You're probably going to have to get a specialized header, whether it's a pan sunflower header, all crop header. That is something you're probably going to have to invest in or work with somebody who has that header that could do that custom combining for you. And as I said before, if you don't have the herbicide options, you may be needing to consider that inter-row cultivation to take care of some of those weeds, especially your broadleaves. You can still use things like Centurion or Assure in your sunflowers, but you don't have a lot of broadleaf options if they're not herbicide tolerant. Pest issues in sunflowers, weeds are probably your biggest, regardless of the crop type, if it's confec or oil, or if you have herbicide tolerance. Really, you probably need to use that pre-emerge herbicide. Just get those sunflowers off to the best start. You're only looking at 18,000 to 22,000 plants per acre. It's not a lot of plants. You need to make sure that the weeds are taken care of so those plants come up and they're developing properly and you're getting the best plant out of it. Sclerotinia is an issue in confecs. We grow confecs. We probably do spray 8 years out of 10. And then if we don't spray, I'm usually stressed out until we combine them just to make sure that we don't have too many heads that have infection. When it comes to oils, they are not spraying necessarily for Sclerotinia head rot, but something I've seen specifically in our area is we're getting a lot of black stem happening in our sunflowers now, and there is the potential for a fungicide to contribute to that. And what the black stem does is it's similar to, let's say like a verticillium in a canola or blackleg in canola. It just very rapidly dries down that crop, and you're not getting the yield out of it. Insects, confections have a lot of issues with insects in the head because you're paid on that perfect seed. You don't want to have a little hole in it from a ligus with a little sour seed inside, or you don't want to have a little hole in it and the entire seed eaten out by another insect. So chances are if you're growing confects, you may be seriously considering spraying for insects as well. And then last but not least, the question was about birds. In sunflowers, they are the bane of my existence at the end of sunflower harvest because sometimes the best that we can do to get that crop off the field quickly is not quick enough. And you can see in here in this bottom picture, the birds will start eating around the edge of the sunflower. And in confects, that's where your biggest seeds are. That's where you're making your money. If they're not there, you're not getting paid on them. So the best ways to combat that is plant early, use a desiccant, and try and get that crop off the field as quickly as possible. One thing to note though, when you're choosing your field for sunflowers, blackbirds like to flock in trees and marshes and bulrushes. And as soon as there's a few there, they seem to talk very effectively to their buddies, and you have all the blackbirds in your field that are wanting to eat your sunflowers. So this is just a tweet that I put out because I do work with a lot of sunflower growers as well. Late season issues, we saw too, a little bit of rust, some verticillium. And then really this one tweet was just talking about timing for desiccation in sunflowers because you want to make sure that you get rapid dry down of that crop so you can combine it quickly, but you don't want to take test weight away. So there is a bit of a science and seed moisture content that you're going for. And luckily, Manitoba Crop Alliance has some pretty good paperwork there of how to figure that out on your own. So drone use. This was another question that came in from Lionel. Again, I'm using the picture of the fellow that had the grasshoppers on the issues, or grasshopper issues on his edges. I like using a drone. I do not find it as a standalone tool. I figure a drone is kind of one of the things in my toolkit for figuring out what's going on in a field. It can identify issues, but you do still need to go into the field and verify them. You can take the drone up, you can identify there's an area of maybe a lot of growth or no growth or whatever, but you need to go in and walk in and actually figure out what's going on. Maybe I don't have a good enough drone, but I cannot get low enough to the canopy to figure out specifically what weed is there or insect damage or something else. I need to go in and walk in and figure out what's going on. I do find too, drones in addition to satellite imagery and boots on the ground is probably giving me my best indication of what is going on in the field and where the issues are. I'm using them kind of in tandem. Sometimes I'm looking at the satellite imagery first, and then I'm taking the drone out, and then I'm going in to walk. Sometimes I'm walking in first, and then I'm using the drone and the satellite imagery afterwards. It just depends on the situation and what I'm trying to identify. I'm finding that using all three of those tools, kind of from as the crop is coming up to timing when that crop needs to be combined, is very helpful. For example, this year, just with the way canola harvest was, and it was slow, on our own farm, we were using satellite imagery and drones to figure out from an aerial view and not, taking the combine in and getting it completely plugged, which areas of the field probably could be combined earlier with the lower seed moisture, and was also using hand samples and threshing it out. And using the satellite imagery drone and then hand sampling actually made our harvests go a little bit faster. It was still extremely slow, but it was just a little bit faster. As well, drones can be used for other things too. I've taken it up looking at hail damage, so you can see in a field, as well as satellite imagery, kind of maybe where the path of the hail went. So if you have a crop adjuster coming, you can kind of tell them which ends to start on. You can provide them that information as well. You can always use it to help engage others within your farm management network. So if you're planning on doing a drainage project, or you have done a drainage project, you can be using some of that drone imagery just to look at that area kind of over time and how it's been changing. It also can help lead to other diagnostics to figure out what else is really going on. In our area too, we're finding that we have areas of fields that have soil acidification, so low pH. Using the drone actually has been very helpful for aerial view to see how big of an area is versus just walking into the field and being overwhelmed, especially if you're in a corn crop. And that's all from me, and I believe that Lionel has some more questions.
Great. Thanks, Anastasia. I guess as you can see by the way the presentation has gone, there's been, I surveyed a lot of producers that actually come on to Crop Talk and listen to what's going on and ask questions during the presentations. So I surveyed them to get some more questions for today. And the previous question, or the last question that Anastasia was answering, was regarding drone use. And maybe what I'll do is I'll get the rest of the panel to maybe give their thoughts. The question was, how do you feel and in what way do you see drones being used in weeds, insect disease control on my farm? Do you think it will start as a custom job like the intro of high clearance sprayers, or will it be more general? So I'm just going to pass the mic down here and see if you guys can maybe give your opinions.
Okay, so for insect control, currently we're not at a point where we can use drones for insecticides. There are some applications for drone use for mosquito larviciding. And I see that probably as where we'll be starting, is things where we're targeting, say, standing bodies of water for mosquito control. That's, again, there's applications for that in already. Down the road, I can see it as a practical tool for insecticide use. Some countries are already doing it. It's just a matter of time, but I think over time we probably will get to that point where we are doing at least some insecticide applications with drones, but again, it'll take a bit of time to get there.
I would echo what John says. I think down the road, we definitely have a lot more applications coming. Right now, there's a lot of drone spraying done elsewhere in the world, just not in Canada yet. We only have a couple of products registered, but I think that is going to be, we're looking at that, and that's probably rapidly changing. So I think, we're not obviously going to be able to spray thousands and thousands of acres, but for spot spraying and that type of thing. And I know for weed ID and that type of thing, I have worked with a company that had a very expensive drone that had really, really good resolution, but it was really expensive. It's not a drone that anybody would be buying and using. It was something that we were using as a company. That one had great resolution. We could pick out individual plants. It was great. For the drones that all of us are using for crop scouting and stuff, I think it's a good tool to use, but I don't think it's not right now replacing boots on the ground agronomy and our weed ID and that type of thing.
In our group, we have a pesticide regulatory specialist, and she's dealing with the mechanics of new products or products being registered for aerial application using drones. And right now, that is extremely limited. There are very few products that are registered for that use. As far as the potential eventually for use in controlling diseases with fungicides, spot spraying, I don't think that's going to happen. My reason for saying that is that with our major diseases that we're concerned about, and I'll talk about Fusarium head blight for one and Sclerotinia in canola for another, you still have to anticipate. Once you see disease, it's too late. So how do you determine which spots of the field are going to be most vulnerable to disease? It's generally a decision still of, do you spray the field or not? So I don't see real practical implications of spot spraying right off the hop. There are some other diseases like the leaf spots on cereals that work their way up from the bottom of the plant. Those you might detect a variation across the field, in which case spot spraying rather than across the field spraying could be effective.
Okay, and I think Anastasia already answered that part. Next, we're going to turn to the audience. Does anybody have any questions for the panel before I go into some of the other ones that I received? Okay, well, the next one I've got here is for Kim. As a producer, what is my responsibility in controlling noxious weeds? Do I need to report them? If they're on my farm, do I need to get rid of all of them? Or if I see them in ditches or neighboring fields, what do I do?
Okay, so in Manitoba, that's a really good question, and that's really relevant now with some of the weeds that we're dealing with, especially something like water hemp. In Manitoba, we have something called the Noxious Weeds Act, and that is a provincial piece of legislation. It's one of the oldest pieces of legislation in Manitoba. It's been here since the province was formed. And so it's in variations over the years. It was recently revamped, well, recently 2017, and there's 3 tiers of weeds now. So there used to be just a big long list of weeds. Now they're in tiers based on basically how bad they are. So tier 1 weeds are weeds that must be destroyed when found. That's our weeds like our water hemp, our palmer amaranth. A lot of the weeds on there aren't necessarily crop weeds. Like they're not going to get into your crops, but they're like ditch weeds, and they displace pasture, wildlife management areas. They get in under trees and things like that. So a lot of the weeds in that tier 1 list really were not that. I mean, they're not really going to affect you guys in your cropped land. But a tier 1 weed, by definition, must be destroyed when found. Tier 2 weeds, they need to be destroyed if they're under 20 acres in size of the infestation, and then controlled, which means don't let it get any bigger. Try to control it, but don't let it expand. If it's over 20 acres, and then the tier 3 weeds are more your agricultural weeds, and then they need to be controlled if they're becoming a nuisance and that type of thing. There's a bunch of different criteria in there. But the ones that we're most concerned about when people are worried about, do we have to report this? We don't have anything legally that says you have to report it, but if that weed is found, so again, once we know they're there, they need to be destroyed. So that the onus is on the farmer. The Noxious Weeds Act is enforced by the RMs at the RM level, but the onus is on any landowner or anyone who is in control of land to control weeds on that land. So that includes ditches and roadsides and wildlife management areas, and that includes pastures and crops, and that includes vacant lots. It includes basically any land that is under the control of someone. That person who's ever controlling that land needs to control the weeds on there based on which tier they're in.
Okay, thanks, Kim. Next question is a 2-part question. It's going to go to David.
Here, Mike.
Oh.
How's that? Okay, the next question is a 2-part question, and it's going to go to David and Anastasia. I heard there's updating on the new Fusarium forecasting tool for 2024. How much different is it than the old one? And I guess the second part I'm going to send to Anastasia. As a producer, have you gone to just spraying, or have you made some decisions, some years decisions not to spray in some fields?
That is a tricky question because it's not us who have been developing that new tool. It's Paul Bullock and Associates from the University of Manitoba. And really what they're doing is coming up with a model that can be used right across the prairie region, a pan-prairie model for showing fusarium risk. And that's a good thing. There are a few elements of the model we've been using for a long time that are limiting, and Paul and his group feel that they have made some improvements. We actually used his model behind the kind of maps that we produce for daily risk this last year. We put an explanation up at the top, what's different, and really it hasn't changed the character of our map. It still shows the daily progression and that risk can come and go quite quickly. Maybe that's all I'll say and get Anastasia's practical view of things.
Okay, so as a farmer, yes, there has been years, probably in the past 5, that we haven't sprayed for fusarium in wheat. Probably 1 year. Sometimes it's only one field. Really what we base our, I guess, decision on whether or not to spray is we are using the Manitoba Ag fusarium forecasts fairly regularly. I am checking that, checking what the forecast is going to be with the chance for rainfall, even though the weather forecasters aren't always right. And then walking our fields quite extensively to look to see if the wheat has headed and started to flower, so in the right stage. So it is very stressful. So the years or the field that we haven't decided to spray, again, you wonder all the way up into the finishing of heading as it's drying down, are you going to have those nice little pink kernels show up in your crop? And then will it potentially start spreading in the head? And I have seen some years where we haven't sprayed that, yes, you will get the odd little pink kernel, and then no, it doesn't spread because the rest of the year has been dry. But then I have also seen where we've made the wrong decision and we didn't spray, and then we did get really humid conditions, we did get infection, and then that crop lost grade because we didn't spray. So you are taking a bit of a gamble. You know, if you want to be confident, sleep well at night, just spray. But if you do want to save money and be very proactive of whether or not you're using those fungicide products, you can get away some years with not spraying, but you have to be very specific on the information you're using and willing to accept the risk and potentially losing grade because you have made that decision.
Can I add just one other thing about that? Yeah, it's your level of risk acceptance or aversion that will determine whether or not you're going to spray ultimately. But whether or not you use the forecast maps, I want to tell you about the science briefly behind how infection happens. You can assume that the pathogen, fusarium, is always there. It can grow saprophytically on plant residues, and it never goes away. It will be driven up into the crop canopy when you have rainfall. So if you've had some rainfall just prior to heads fully emerged, that's a good chance that there are spores up and around in the air. And then infection happens when you have the unique coincidence of high humidity, that's above 85%, and warmer temperatures. Often humidity and temperature go opposite to each other. But humidity above 85%, temperatures between 15 and 30, coincidental with flowering. That's the window, which is the bad window for infection to occur. So if you see things lining up that way, you'd probably be best to be prepared with a fungicide.
Okay, and I think I got time for just one more question here, and unless there's somebody in the audience I'm missing. Okay, John, this one's going to be for you, and it's about grasshopper control. I'm a producer in southwestern Manitoba, and last year had severe grasshopper issues. For control this spring, how early, hot spots, should I be looking for those areas and baiting them sooner? Just some comments that way.
Okay, so there's a couple of points there about how early and baiting. So first, the how early part. So we've got different species of grasshoppers. They don't all hatch out at the same time. I mentioned in my talk about how if we get a warm fall and you get good embryonic development, things start coming out earlier. We did have a warm fall. If we get a warm spring, two-striped grasshopper will probably start coming out about late May or early June. Very closely followed by clear-winged grasshopper, and then migratory, they come out a bit later. So because of these multiple species, you get this very almost staggered emergence. Also depends on when the eggs were laid in the fall. Any time between late May to late June is when egg hatch will likely be happening. Clearwing, the grass specialist, it goes through its young stages really quickly. So that's often the one that we see a lot of adults, often by the beginning of July. Now regarding baiting, EcoBrand is the brand bait that is available on the market. It can work well. A juvenile grasshopper, even 1 or 2 flakes will kill it. Adults, it takes a few more flakes for them to be killed. They certainly can kill the adults too. They just have to eat more flakes. If you're trying to figure out when's the best time to target baiting, so when grasshoppers develop, they go through about 5 stages before they become adults. When they get to their middle stage, that's the ideal timing. And you'll know they're in that middle stage because you'll see, if you look carefully, these little wing buds on the back. When they first hatch, they're about the size of a wheat kernel. That's too young. There's probably a lot of eggs still in the ground that haven't hatched. But as they get bigger, you'll start to see these little mini wings on the back. We call them wing buds. And when most grasshoppers have those wing buds, probably most of your hatch is done. That's the ideal time to be controlling grasshoppers. If you go too early, you may end up doing it a second time just because more hatches occurred. But I'll put in the precaution, if you've got extremely heavy populations and they're doing a lot of damage, especially to the edge of your field, there might be times when you might want to go a bit on that earlier side and then maybe have to do it again. The other thing, if you're using a foliar spray, there are some on the market with really good residual, and if you are spraying earlier than is ideal, if you're using a foliar spray, consider something with a bit of residual to it.
Okay, thanks, John. And that's going to end our morning session here with the Crop Talk. Just one plug, if you're interested in registering for Crop Talk, the slide is up there. The QR code is there as well, and that'll take you right into the registration. So there's credits sign-up sheet at the back. And thanks for attending. Thank you, panel. You were great. Always good to work with you guys.